Hey guys, today we're talking about properties of exponents. If you had 2 cubed, you would take 2 and multiply itself by 3 times, right? So 2 times 2 times 2 would be 8. So if you were just solving that, that would be fine. But what if you had 2 to the 3rd power times 2 to the 4th power? What that looks like is 2 times itself, one set of 3 and one set of 4. So really, to simplify it, there would be 7 2's, so 2 to the power of 7. If we have 5 squared and 5 cubed, that would be like 2 5's and 3 5's being multiplied by each other, or 5 to the 5th power. And then if I have a squared and a to the 4th power, it would be like a, and again, you get a to the 6th power. So what do we see going on here? We see that if I have the same base, okay, of 3, that the factors, when multiplied out, end up having, in this case, like 6 factors, so 3 to the power of 6. So to multiply the powers with the same base, you add their exponents. This is what it looks like in algebra. Same base, like a base of a, you would just add m and n to get whatever number. In this case, 2 to the 4th power, 2 to the 3rd power is 2 to the 7th power. Okay, what about division? If I have y to the 5th power divided by y to the 2nd power, it's like having 5 y's written out on top and 2 on the bottom, which means on top I'm left with just 3 y's. Same thing over here. X to the 3rd on top would be 3 x's and 2 on the bottom, and only 1 is left over. So what's the shortcut? The shortcut is that you subtract the y, or the exponents, and leave the base the same. Okay, so what happens if I have y to the 3rd power divided by y to the 5th power? Okay, again, I have 3 y's on top, 5 y's on bottom, and these cancel out, so I'm left with 1 over y squared. So again, if I would have taken y as my base and subtracted 3 minus 5, I get 1 over y squared. So again, the shortcut is to subtract. Okay, now the big thing is you divide the powers with the same base by subtracting their exponents, as long as your base is not 0. Okay, so 5 to the 7th power divided by 5 to the 4th power would be 5 to the 3rd power, because 7 minus 4 is 3. Or you could factor them out and then cancel. So you can always check your work that way, but that can be a little tedious. All right, so find the number that correctly completes the equation. I want you to try this on your own, and I'll be back in just a second to show you what I did. You know the base is y, so what does a have to be in each situation? Red pen ready. All right, so what you're thinking is, what could I fill in here to make this a true statement? Over here, it would have to be y to the 9th power, because 5 plus 9 gives you 14. Over here, it would have to be 22, because 3 plus 22 gives you 25. All right, go ahead. Oh, just kidding. This is something new. So we have powers to a power here. I have 8 to the 4th power, and this is being cubed. So what does that really mean? Same thing over here, k to the 7th power, and it's being multiplied to the 5th power. So what this really truly means is you take 8 to the 4th power times itself 3 times. When you do that, it's like factoring out 4 8's, and there would be 3 groups of them. So this would be 8 to the 12th power. What's the rule then? The rule then is you can either add the 4's together 3 times, but repeated addition is the same thing as taking the base and multiplying, right? 4 plus 4 plus 4 is repeated addition. We've seen that before, which we know is the same thing as multiplying by 3. So over here, all you have to do is take 7 times 5 and get k to the 35th power. Algebra-wise, what does this look like? Again, 6 to the 4th power to the 5th power would be 6 to the 20th power. You factor it out, and repeated addition is the same thing as multiplying those powers together. So 5 to the 2nd power to the 3rd power would be 5 to the 2nd power, and you multiply 2 by 3 to get 6. So this is what it looks like in algebra. Okay, what if we take it a step further and you have another number in the parentheses? Then that 4 that's your power gets distributed to both pieces, both the 4 and the p. So in this case, this is a p cubed and this is a 4. So it becomes 4 to the power of 1, p to the power of 3. So you multiply both by 4. So 4 to the power of 4 and p to the power of 12, because 3 times 4 is 12. Try this one for me, and I will show you in just a second. Okay, this one's different because the 4 is outside, so it does not have this power attached to it. So really, it's just 4 times p to the 3rd power to the 4th power, which is 4 times p to the 12th power. Okay, you should have 3 rules in your notes. Oops, I'm sorry, I'm clicking a bunch of different slides here. You should have 3 rules in your notes. 1 for powers to a power, which is this slide, which is a base, same base, but different powers. So you are taking and you are multiplying powers. Here you are dividing powers, or excuse me, here you are doing power to a power, and here you are dividing powers. So you should have those 3 rules. You should also have 11 examples written down in your notebook. That's all I have for you today. See you next time.